Let's start with chapter 24, the Earth and the solar system. The Earth, Moon, and Sun. Earth's motion, rotation. Earth spin on its axis once every 24 hours. Axis tilted 23.5 degree to the vertical. Causes day and night. Sun's apparent daily motion rises, moves across sky and sets. Revolution, orbit. Earth orbits the sun once every 365 days, which is a year. Day and night. Half of Earth facing the sun day, half facing away, which is night. One full rotation is approximately equals to 24-hour daily cycle of day and night. Apparent motion of the sun due to Earth's rotation, not the sun moving, appears to rise in the east, sets in the west at noon, highest point in the sky. At the equator, day is equivalent to night is equals to 12 hours all year. Away from equator, day length changes with season. Equinoxes and solstices. Equinox, spring, approximately 20th March. Autumn, approximately starts from 23rd September. Day is equivalent to night. Sun appears to rise exactly east and sets exactly west. Summer, northern hemisphere, sun rises NE, sets NW. Higher path across sky, longest day at summer solstice, 21st June. Winter, northern hemisphere, sun rises southeast and sets southwest. Lower path across sky, shortest day at winter solstice, 21st December. Important. Seasons are caused by tilt of Earth axis plus orbit, not by Earth being closer or further from the Sun. Seasons, hemispheres, and comparison. When it is summer in the northern hemisphere tilted towards the Sun, more solar radiation. Southern hemisphere tilted away, winter there. When it is winter in the northern hemisphere, northern tilted away, less solar radiation. Southern hemisphere, which is summer. Let's talk about the moon and its phases. Moon's motion, natural satellite of Earth, orbits Earth in about 28 days, which is 1 month. Rotates once every 28 days, same side, always faces Earth. Why we see phases? Moon reflects sunlight. It does not produce light. Half of moon always lit by sun. We see different portion of the lit half as it orbits Earth. Main phases: new moon, day 0, moon between Earth and sun, and lit side faces away from Earth, not visible. First quarter approximately day 7, right half visible from an hemisphere. After new moon, crescent first quarter and then waxing gibbous. Full moon approximately on day 14. Earth between sun and moon. Lit side fully facing earth, whole disk visible. Last quarter approximately day 21. Left half visible from an hemisphere, which is north hemisphere. After full moon, warning gibbous. Last quarter, morning crescent. Back to new moon, day 29, and cycle repeats. Now let's discuss the solar system. Main components: 1 star, the sun; 8 planets, dwarf planets, natural satellites, moon, artificial satellites, asteroids, and comets. Planets in order from sun. For mnemonic, my very excellent mother just served us noodles. So we can learn Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Inner planets rocky: Mercury, Venus, Earth, Mars. Small, rocky, higher density. Outer planets gas giants: Jupiter, Saturn, Uranus, Neptune. Large, mostly hydrogen and helium, lower density. Dwarfed planet similar to planet but smaller. Gravity not strong enough to clear nearby objects from their orbit region. Satellites: natural satellite orbits a planet, example moon. Artificial satellite man made objects placed in orbit, example ISS. Let's talk about asteroids. Small rocky objects orbit the sun, mostly in asteroid belt between Mars and Jupiter. Comets, made of ice and dust, travel in highly elliptical orbit around the sun. Near the sun, ice melt, tail forms point away from sun. Who orbits what object and the orbits planet? Orbiting sun, moon, orbiting planet, asteroid orbiting sun, comet orbiting sun elliptical path. Artificial satellite usually Earth or other body. Let's talk about formation of the solar system. Accretion model. It started as a rotating nebula, cloud of gas and dust. Gravity pulled matter together, cloud collapsed. Center became dense and hot, formed the sun. Remaining material formed a rotating accretion disk. In the disk, particles stuck together, accretion, formed planetesimals, then planets. Why inner planets are rocky and small? Inner region near sun is hot. Only materials with high melting point, metal, rocks could stay solid. Heavier elements are less abundant, so inner planet stayed small and rocky. Why outer planets are gas giants? Outer region equals to cooler. Light elements H and He and ice, water, methane, ammonia could condense and stay. Huge amount of gas collected, very large gaseous planets. Let's discuss about light speed calculation. Light speed c equivalent to 3.0 times 10 power 8 meter per second. Light from sun takes 8 minutes approximately to reach earth, approximately 5 hours to reach outer solar system, and approximately 4 years from nearest star after sun. We can use it in a formula: speed equals to distance over time, or if we need to calculate time, which will be equals to distance over speed. For light, t equals to distance over 3.0 times 10 power 8, and then you can put the other variables and find out your third variable. Now let's discuss about gravitational field strength and orbits. Gravitational field strength G depends on mass of the body. Larger mass, stronger gravitational field at its surface. Distance from the body, further away, which means weaker field. At a planet's surface, G is approximately constant. Example, Earth is approximately 9.8 Newton per kg, but it decreases with height. Gravitational attraction of the sun. Sun has greater than 99% of solar system mass. Gravitational attraction of sun keeps planet in orbit. Force always acts towards the sun's center. Now let's discuss orbital motion and distance. For a stable orbit, there must be a centripetal force. For a planet, centripetal force is equals to sun's gravitational attraction. As distance from the sun increases, sun's gravitational field is weaker. Orbital speed decreases. Orbital period increases, takes longer to complete one orbit. Let's discuss orbital speed equation. For approximately circular orbits, we have formula V equals to 2 pi r over t, where V is orbital speed, uh, unit is meter per second. R is the radius of the orbit, unit is m. from center of body being orbited. T is the time period for one orbit and its unit is seconds s. Remember always to convert kilometer to meter and convert minutes to hours and to seconds. Let's discuss about elliptical orbits and comets. Elliptical orbits. Most orbits are elliptical, not perfectly circular. Planets almost circular, sun roughly at center. Comets highly elliptical, sun at one focus of ellipse. Speed in elliptical orbit. When nearer the sun, stronger gravitational attraction. High speed, smaller radius of orbit section. When further from the sun, weaker gravitational attraction, lower speed, larger radius. Energy changes, total energy conserved close to sun. Gravitational potential energy decreases, kinetic energy increases, which means speeds up. Far from sun, gravitational potential energy increases, whereas kinetic energy decreases, slows down. With this, we have finished our chapter. See you in our next chapter.